What is up, YouTube? In this video, we are going to look at what is infrastructure as code and why it is an important tool for data engineers. If you find videos like these helpful, please like and subscribe and help support the channel. So let's look at some issues of the past. In the past, if you wanted to deploy an application, first of all, you need some hardware in place. So you would get some servers, then configure networking with these servers in place, install all the dependencies, requirements, etc., have an environment in place, and then finally you would be able to deploy this application. In the past, all these steps were kind of done manually, specifically by system administrators. Their whole sole job was to deploy these applications and was kind of done manually when they used to go to this graphical user interface, click on buttons, do some things, do their magic in place, and then run the application by the end of the day. But this kind of involved a lot of human interference in a way. And then things also kind of become really cumbersome for them because there were like multiple environments involved, like development, staging, and production. So these kind of steps, which were done manually, had to be done manually again and again on these different environments. So now in the new age of DevOps, things are actually really different. In general, it can be broken into like four main parts. For compute, we have multiple different options. One is VM, other is a cluster, serverless functions, and then containers, which is like a small packaged code with dependencies. For storage, there are also multiple options, including database services, which are independent of VMs, other things such as object storage, such as S3 and GCS, etc. There are a lot more other things and multiple databases which can be involved, hybrid databases, OLAPs, such as BigQuery, and then there's the regular NoSQL databases, such as Firestore in Google Cloud, and then there's DynamoDB in AWS. There are also foundation things which needed to be taken care of, such as networking and the right access in place so that no bad actors can access your infrastructure. You also need to implement logging and monitoring so that in case of if your app crashes, if there are errors, you can easily debug them later on and figure out the fixes. And then the last stage is more like applications where you actually deploy your code. Usually nowadays it's being done using Docker or any other package containers as images. You kind of build these images and deploy it as containers on VMs, clusters, etc. Even like there are services such as Cloud Run, which you facilitate that. So actually there are a lot more options nowadays for you to figure out. And then, for example, a typical application infrastructure can kind of look like this, where it has a lot more different microservices which kind of interact with each other. Also, with the new age of cloud, it involves a lot of elasticity where you can scale up or scale down your infrastructure in a matter of seconds or minutes as required as per your load. In a way, achieving this kind of complex application infrastructure and scalability can only be done by automating it using infrastructure as code. Hence, it's kind of a standard practice in place in almost every company in the world. Important aspects on why a data engineer might use infrastructure as code can include version control, multi-cloud deployments when there are like multiple clouds involved, when the frequency of deployment is quite high, when you do it on a daily basis or weekly basis, then it's kind of very important to use infrastructure as code. Less prone to error and issues is another. So there are a lot of tools in infrastructure as code ecosystem for you to choose from. Some of them can be really specialized, some can be really generalized in terms of their usage. They kind of exist, these multiple tools kind of exist because they, in a way, some of the tools serve different purpose and different steps in the automation as a whole. So a lot of the times people use them in combination. For example, I've generally used Ansible in combination with Terraform, where Terraform is kind of being used as just declarative language for me to render the infrastructure, and for application deployments and configurations, I use a mix of Docker and Ansible together. So all these technologies kind of bind up and augment each other in terms of their functionality and makes the whole process kind of seamless. But the idea is these different technologies are kind of targeting each step of the process. There are multiple steps, so they're kind of targeting specific steps of the process. They can overlap. Ansible is more like a hybrid language, which also can be used to provision infrastructure. So they have their own pros and cons. All right, moving on. I will build a small project using Terraform. I'm going to mainly using Google Cloud for this. So the idea is I will create these Terraform scripts in this repository. I will leave the link in the description as well. Let's cover a few basic aspects. Terraform is from HashiCorp, the organization. So the first thing you need to do is you need to install Terraform on your machine, from which you're going to execute these scripts. Most likely it's your local. There are a few options for you. If you have a Linux, you can use sudo apt-get, and then for other versions, you can use whatever package manager they have. There's some Choco on Windows you can use as a package manager to install it. My preferred method is, because I'm using a Mac, I'm going to use Homebrew to install. So the very basic idea is you just you run these two commands, you tap on this repo, and then you just install it. It's going to take some time if your Homebrew is not updated. That's what happened for me. I haven't updated for a long time. So once you update the Homebrew, then I think it's just very straightforward, just installing these two commands. So once you have Terraform in place, you should be able to just do Terraform help to see if it's installed correctly. So yep, looks like things are working. So I installed just a few minutes back. That's it. The main.tf is where all the infrastructure code is here. Variables is like the input variables you want to try to provide. So basically provide default variables or production or staging variables. It can change from environment to environment, but this is how it looks. So you provide these variables. Because I'm going to deploy this on Google Cloud Platform, I need these few key variables to be figured out. So one of this is the project ID. You need to create a project in Google Cloud Platform. That's what you're going to do. So go to GCP, Google Cloud Platform, create a project, and then you need to download a service account. I'm going to leave a link in the description. So basically you go there on the platform, create a service account. Service account is where you can access Google services using code. So it's just a JSON file with all the credentials. I'm not going to open it here, but in general, it's just a JSON file you're going to use. So this is where the credential file is. You're providing a path. All right, moving on. So I'm going to show a demo on how the main file looks like, the main Terraform file looks like. The first thing is you need to give a provider which you're using. Basically, Terraform supports a wide range of cloud providers which you can easily integrate. So Terraform has already been doing the development for a long time. It's a very stable product. It supports a lot more cloud providers in general. So we are going to use the Google one. But if you want to go back to the website and check out the providers, these are the ones which Terraform supports natively, including like all the main ones: Alibaba Cloud, Kubernetes, AWS, and then even the small ones as well. So yeah, that's the first thing. So you're using the required providers. If it's a multi-cloud deployment, you're going to specify that here as well, that if it's AWS, you specify AWS. So as a next step is, if it's a Google provider, you need to initialize it in a way that you're saying for the Google Cloud provider, I need all these items which we initialize in the variables.tf file, be it the project name, region, zone, and the credential file itself, which is here. And as a next step, we're going to create one of the first things. We're going to create a network infrastructure for us. So yeah, we're creating a VPC network so that the VMs can be attached to this and can be used later on. So that's the first step you do. And then like as an example, we're going to create one of the first components in the cloud using Terraform. So yeah, let's try to execute this and see what's happening. So the first thing you need to do is, once you have Terraform installed, you need to initialize these scripts and say in Terraform init. It's going to figure out things on its own. Because it's declarative, it's going to create a state. It's going to create a few more files within it. You can safely add it to git ignore, but the idea is you can usually commit this to kind of maintain the state. You can keep it instead of keeping on a git, you can keep it on a GCS repo. There are a few options you can use to maintain the state, so that anyone working with this repo have the state in place. So it's not a fresh install every time. So yep, so the repo has been initialized. It's maintaining the state. No new things have been created. It just has initialized this folder for us to use. So we can just see what thing's going to happen using Terraform plan. So I'm going to execute it and see what it is supposed to install. For Terraform plan, it shows that, hey, these things will be installed later on when you execute the apply command. So basically, Terraform plan will describe what will happen when you're going to do Terraform apply. So it doesn't execute things right now. It's just going to show you what the plan is, what is going to happen when you apply the changes. So one of the other things is you can do Terraform format. So for example, if the format of the Terraform file is not looking good, you can just do Terraform format. It will auto indent the Terraform files for you to use. One of the other things we can use is Terraform validate. In validate, it will see if the scripts are all right, and they can be used to perform the application. All right, so the last step is to do Terraform apply. This will apply the changes and create this VPC network, basically render our infrastructure on cloud. Show me the same things which were shown in part of Terraform plan. So these things will be added. So new service will be created, new infrastructure will be created. So I'm going to do yes and see if it creates or not. All right, it is creating the network. So let's just wait for it. All right, so the VPC network has been created basically. So yeah, the apply has been created, has been done. So we have the Terraform network in place to be used by the VMs which we are going to create next. So as a next step, let's create one VM alongside with this VPC network. So basically the VM will use this network to interact. So moving on, the first step, we are going to write down the resource we want to create. So similarly, what we did here, we're creating a resource called Google Compute. So first we created a compute network. Now we're creating a compute instance. So we need the network in place before we create the instance. So we are going to call it as Terraform instance and provide the machine type. So as the next step, we are going to provide a boot disk for it. So we're going to provide an image of a Ubuntu image so that this VM is loaded with an operating system with the image Debian Cloud Debian 9. So basically it's a Linux image. You can change it. You can change it now. You can change it later on and apply the changes. And as a last step, you're going to create a network interface. So basically this VM will be using this network we created, this VPC network. So which is this one. Things are looking good. Our VPC network has been added. Let's just try to apply the new changes. So that's how it works. It figures out the Terraform is not like a linear code or a procedural language. It's more like a state-based language. We will provide the end state which we want. We want a Terraform instance with this image using this network, and it's the goal of Terraform and the role of Terraform to kind of figure this out on its own. Terraform, and I will do apply. So in apply, first let's do plan and see what is going to happen. It will share what is going to happen next. So as we do plan, we can see things will be created. So basically this block of code we mentioned. So all these parameters are being created once we do apply. So let's try to do Terraform apply and see what happens. All right, so it's creating the VM instance now. Let's just wait. It's going to take a few minutes because Google Cloud takes some time to render the instance on the back end basically. Yeah, Google Cloud instance has been created for you to use now. You can also output the values of the IP that has been created. Let me try to figure that out also. So basically I place in the output variable that show me the IP of the instance I just created so that I just know it here. So let me do Terraform apply again and see what's happening. Hopefully it's not going to recreate the instance. Yeah, so it will provide the changes to the output, which is it's going to provide this IP. So let me see. All right, so it did not create the resource because it has the state in place that the resource is there for you to use, and the IP of the resource is this. So, which is great. We finally have created a VM with a network and an image already for you to use using Terraform. So yeah, that's the basic idea. And the next step, if you want to change, like for example, if you have multiple VMs here, you can just go about adding or subtracting this block of code. So if I just subtract this block of code and apply the changes, it will remove this basically. And then if you want to destroy everything, delete everything in this file, you can just go ahead and that's what I want to do now because it's a sample project. I'm going to do Terraform destroy. So it will show me the things it will delete. So yeah, it will delete the project. It will delete everything. So it will delete the network. It will be deleting the VM, and the IP will not be there because we are destroying. So I'm going to do yes, and let's see what happens. If you found the video to be helpful, please like and subscribe. It will support the channel a lot.